Adepoju, if I say the name well, just leave this link and go to the other link. There are two links, one for room 1 and one for room 2. Please leave this room. Thank you very much. Okay. Very good. Hello, everybody, again. We are just about to begin. We are just waiting for 1 or 2 minutes for the other mentor to connect. Our IT group will connect Professor Despotovic, Jovan Despotovic, that we are waiting. And this is the thing. We will just start. Yes, he is in. Okay. Hello, Professor Despotovic. How are you? Okay.
Very well, and you?
So I think that we are okay now. And I think that we can start our session now. This is session 3. We are in room 2, and we are about to start theme 1, which is water-related disasters and climate change. Here we have the 2 mentors. We are welcoming all of you in this session. Thank you very much for being here and participating in this interesting 3-day event with many various and different things that are happening. It's not only the papers, it's the advocacy workshop, it's the round table. We do have a lot of things to exchange, a lot of discussion to trigger, and we hope that we come out with very interesting conclusions. I would like to ask first, I would like to introduce you to the 2 mentors. I will just say a few words for the first one. He will do his speech, and then I go to the second one. I will introduce him so that you have the idea of each one of them. So I will allow me to start with Professor Jovan Despotovic. Professor Jovan Despotovic is a very well, thank you very much for being here, for supporting the World Water Forum, for contributing in this effort, for having the time and the will to exchange your experience and your expertise with all these young people and with all of us, of course. Let me just introduce you. Who is Professor Despotovic? Professor Despotovic received the thesis at the Faculty of Civil Engineering, the Department of Hydraulic Engineering. He was engaged as full professor in hydraulic engineering and fundamentals of hydrotechnics and hydrology, and several subjects in doctoral studies. He was trained at the University of Ottawa. His main areas of research include measurement, analysis, as well as statistical and numerical stochastic modeling of precipitation processes and runoff in urban areas, but also he's an expert on drainage and sewage systems. He is the author of the textbook Rainfall Runoff Drainage. He has authored many chapters for lectures and papers in several conferences and high-ranked journals. He has led and participated in international, EU and national scientific projects, being board member at several conferences, reviewer in well-known journals like Water Science and Technology, Urban Waters, Environmental Management, and so he is the advisor in the government of Serbia, and also advisor in the Electropower Serbia. Also a member of the Serbian Chamber of Engineers, Board of Directors of the Institute for Multidisciplinary Research, IMSI. He's doing research on the use of fly ash in several areas in construction. And also he has very long journey, let's say, on several projects, and he's both an engineer of academia and of practice. So he has a lot to say to us. He is a president for the Commission for taking professional exams for hydro design engineering and builders in the Serbian Chamber of Engineers. He is the member of for UNESCO, the Republic of Serbia, chair for the IHP UNESCO Serbia, vice president of the Bureau Council of IHP of UNESCO, and representative of the part group 2 in UNESCO from 2010 to 2013. I don't want to tell you more. He also is a member of the UNESCO Center, International Research and Training Center for Urban Training since 1988. And now he is the chairman of the board of this UNESCO Center. And mainly I would like to give the floor to Professor Despotovic to share with us his presentation. Can you please, you are muted.
Sorry.
Okay, that's fine.
Okay.
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 Thank you very much.
Thank you very much for inviting me to be amongst these really nice worldwide people, young researchers and more experienced ones. And this is a really nice opportunity in these tough times, accounting for COVID consequences and for turbulent times in Europe, and to continue this nice idea of exchange of ideas and experience worldwide. I would really like to congratulate to you, to your team, to the Aristoteles University of Thessaloniki, and all of the participants, particularly young people, to share their ideas and first steps in research, or let's say the first phases of their research, with us, who spent, as you mentioned, even decades in the field of water and in the field of water resources. To my consideration, I think that not only Africa, but also Mid-East, far Asia as well, and many other parts of the world have a lot of problems with water. Not only the climate change, not only the complete exhaustion of water sources in the world. If we don't pay much more attention to that, would lead to very difficult times in next 10, 15 or 100 years. So we will not be facing or witnessing the consequences, but we can project, accounting for our experience in the last 30 to 50 years, that the water is probably the first resource and the first precious part of the earth. Although more than 70% of the earth is water, we are very keen to destroy this sweet water or drinkable water of sources, or sources for drinking, irrigating, etc., etc., the other purposes of water. So I would share my experience with the participants in this session, but maybe at the end of this meeting, the day after tomorrow, we will be in a position to conclude to a more general level what would be the most important steps in the future of research and design projects and construction works, maintenance and operation of water systems. Once again, I would like to congratulate to your center for developing this idea very, very nicely for the time being. I hope with a lot of success with while participating so many people from the world, we can say, from the whole world, we can say freely, and that we can gain some experience that will be challenge for the next research works in the future. Thank you very much again.
Thank you very much. So you are just, we are going to proceed with the second mentor, and then the authors will present their work, and the two mentors are there. First of all, they will chair the whole session, but they are there for question, for discussion, for whatever you need and you like to ask. We all be here for you. Thank you very much, Professor Despotovic. I also want to welcome you with us and thank you for being here with us, Professor Ramesh Chigavarapu. It's well known as Dr. T, coming from the Florida Atlantic University in the US, in USA. And just to introduce you to Professor T, he's a professor, a Fulbright scholar and specialist graduate program director in the Department of Civil, Environmental and Geomatic Engineering. He is the founder of the Hydrosystems Research Laboratory at Florida Atlantic University in the States. His main research interests include climate change and variability, hydroclimatic extremes, water and environmental systems modeling and management, spatial hydrology, and hydrometeorology. Dr. T is an author and co-author and sole author of several books on these topics, along with several book chapters and conference and journal publications. I would like to give the floor to Professor T. It is easier to use this short name to everybody to share with us his presentation, and then I will give the floor to the two mentors to chair the whole session. Thank you very much for the authors, the whole group of participants that are here with us, and we have this amazing opportunity, all of us, to exchange, to trigger the discussions in this three-day Congress. Thank you.
Thank you so much, Elpida. I really appreciate giving me this opportunity to join this Congress. And I, as our other panelist, Dr. Despotovic, has indicated that we have a tremendous amount of talent with young as well as matured researchers in this forum. And I think this will be a great success to have after the challenges we have seen with COVID and other issues. So I'll give a small brief talk about hydroclimatic extremes and climate change, which is quite important, especially when we are handling different types of problems around the world. We all know that climate change is a gradual progression of changing the climate. We might see changes in the mean or variance or inclusion of both. We also see the dance of the climate, in this case, the natural climate variability that causes many problems around the world. What we are seeing in future is that not all parts of the world experience the similar type of climate change. In some parts, it is getting hotter, and some parts it is getting more rainier. The other parts are experiencing colder waves as well as droughts and so on. So this becomes a huge problem where, because we have this non-uniform distribution of the hydroclimatic extremes, both in space and time. So we all know this diagram. We've been seeing the global warming taking place. This is the most recent data sets indicating. And then we also see the overlap of the carbon dioxide concentration, which is one of the main contributors to the global climate increase, temperature increases. We can also authoritatively say, based on the data available, but based on the number of simulation models using climate change models and so on, we can see that the observations align very well with the anthropogenic influences we are imposing on top of the climate. I mean, you can see the natural climate, if it continues without the anthropogenic influences, the graph would be different, but the observations are aligning with respect to the anthropogenic influences. So that indicates that there is discernible evidence that we are influencing the climate. And we also see the sun's climate cycles, and that is affecting our global temperature. But we do see that similarities in terms of the variations, but we see the increases in the temperature. This again is a similar graph I have shown you, which indicates that we are indicating the anthropogenic influences. The other one is the climate variability. We call it as teleconnections, which are affecting different parts of the world in different ways, the climate anomalies across the world, and that is due to natural cycles. Of course, sometimes it's difficult to distinguish between the natural cycles and the climate change. So if you see here, these are some of the teleconnections which are influencing different parts of the world. They are called oscillations, and you can see every single continent is affected. Of course, the regional influences are different. For example, Japan is influenced by ENSO and PDO and so on. India is affected by El Nino oscillation and Indian Ocean dipole. And North America, you can see a number of oscillations affecting. And similarly, some parts of the Europe and other parts of South America are affected by these oscillations. So the temperature impacts, as you can see, sometimes based on whatever part of the cycle you are, it will have impacts. For example, this is the ENSO impacts, the precipitation impacts, temperature impacts in different parts of the world, where you have either warmer tendencies or colder tendencies, depending upon which parts of the world you look at. And here's an example of how climate change is affecting. This is based on my research in Japan, and you can see that as we are progressing into the later part of the century, your temperatures are going up. So that has implications on agricultural products, tourism, and so on. So that definitely has impacts on all sectors. This is an impact of the temperatures due to ENSO in Japan. And again, I can see that the La Nina taking over El Nino, and that affects the higher temperatures in the month of September in different parts of the year. This is another example from India. You can see that how the temperatures more than 30 degrees are going up in different parts of the country. This is going to affect agricultural production because a degree change in temperature will affect the yield of rice and other commodities. And this is, again, the progression of the El Nino, La Nina in India as we move from June to September, the monsoon season, which is the main important season for agricultural production. So again, you can see the impacts. This is the different precipitation indices, the totals, dry days, and so on. Again, the influences are non-uniform, and we need to understand how these influences are affected. The sea level rise is a big issue. Where I live, for example, in Florida, we have huge issues with respect to sea level rise. Sometimes sea level rise can help us to solve problems. This is an example of an island near India and Bangladesh. Because of the sea level rise, a disputed island is now no longer a disputed island. So sometimes maybe it is helping in some form to solve the problems. But here's my data suggesting I picked up approximately 500 stations around the world. And you can see the increasing trends in most of the parts of the globe. in terms of the sea level rise. Here's another problem, what we call the nuisance flooding. This happens in Miami and different coastal areas because of the sea level rise. And top of that, the king tides, the water comes into urban areas and causes problems in the urban settings, which are located on coastal areas. These are the trends in different months in United States, and you can see that most of them, excepting on the West Coast, you see some statistically non-significant changes in the sea level rise. Again, the same thing. So what do? We have to think about planned retreat. This is what is going on in Florida. We are accommodating the sea level rise. We are trying to protect properties with seawalls and so on. Of course, these are temporary, so we need to think about what we can do about sea level rise in future. And if the projections are right, half of Miami in Florida will be underwater. So the future climate challenges, of course, every part of the water sector is affected by either hot or wet or dry conditions, and it affects every part of the production from agriculture to hydropower and so on, from water quality to diseases which are spread by increased temperature. So we have a lot of sectors which are intercombined with water are affected by the climate change. So what are the challenges? The rising sea levels that will cause coastal level floodings. We have storms, surge flooding, non-uniform temporal variations of temperature and precipitation in different parts. We see that temperatures are increasing in different parts of the world. That has impact on rice and other agricultural products in developing countries like India. Non-uniform spatial temporal variation of precipitation. This is happening across the world. It might introduce water stress, increased urban flooding and extremes. And of course, every sector from tourism to health will be affected by climate change. We know that. So what do? We have to do more comprehensive studies to understand the climate trends, potential links between hydroclimatic variables, look at the oscillations, look at the data available, look at the multiple influences of these oscillations, look at the data at the finer temporal scales also. Regional analysis is required as opposed to global analysis because the influences are non-uniform. We need to do that, and that will help us to understand both the climate variability and climate change impacts on hydroclimatic extremes. So, of course, we need to come up with sustainable water resources management options. Maybe we need to change our hydrologic design, new methods to understand how we can assign preferences to our infrastructure designs. Maybe we can also look at the water management officials and hydrological designers to understand how we can improve the infrastructure design in future. So thank you so much for the attention. I don't want to take away time from the actual speakers. There are a number of books we have published, some of them with collaboration with LPDA and IHR task committees. You might be interested in looking at some of these books for some very regional studies, giving a lot of insights into what is going on in different parts of the world in terms of climate change and variability. Thank you so much, Alpida. I'll stop here so that we can give some chance to other speakers.
Okay, I think that we should start. Elpida is probably at some other place, or
no, she's not. She's here. She's everywhere.
I'm kidding. Okay.
You know, Elpida.
Nice.
Let me just tell you that Elpida in Greece means hope.
Yes.
The name means hope.
Oh.
So we all hope that it's going.
So
to go
we Elpida, that hope is here.
The hope is here. Thank you very much, Professor T, for this inspiring presentation that I'm sure that it will produce good discussions, and I give the floor to our mentors to share it. I will be here to listen. Thank you very much.
Okay. If I may add to the very nice presentation of our colleague T, the problem is even worse with the water resources management structures, etc., in the systems, because those that we are using nowadays were designed constructed and maintained for maybe 5 decades or maybe 100 years. So we have to improve all of those. And so the management and the operation of all systems is even worse problem than colleague T expressed about the general conditions and perspectives for design and maintenance. So let me invite the first speaker for today, if I may.
Yeah, sure. Go ahead.
Aishwarya Avari from India, groundwater potential zones mapping of Nanak Sagar catchment using GIS, remote sensing, and MIF technique. Do we have Aishwarya?
I don't think she's in the seminar session right now. Maybe we can invite the next speaker.
Yes. Yes. Okay. So then Teresa Margarida Xavier de Melo Lopez. She's present from Brazil.
Hi, I'm present. I'm ready.
Welcome.
Can you see my presentation? Yes?
Yes.
Yes, we can see. You can
Yes.
put it in the complete slide mode if you want. Yes.
Yeah.
Yeah.
Thank you.
Thank you. Hello. Good afternoon. My name is Teresa Lopes. My paper title is Analysis of the Influence of Socioeconomic Variables on Urban Water Demands. The paper was made by me and my colleagues, Duarte Jr. and Jessalom Shoa. I study in Federal University of Ceará, and my advisor is Samir Oliveira. So, my paper is related to water shortage and decision tree and socioeconomic variables. And in this context, the water shortage is very worrying because it generates social and economic and environmental problems. So one of the things that generates the water shortage is the imbalance between the water demand and water supply. So it's necessary to know the aspects that interfere with urban water demand. And in this context, decision tree is a method that have been used in studies by water demand projection model. And several studies consider the different socioeconomic factors. Continuing, my paper identifies the socioeconomic variables that must contribute to the water demands of Fortaleza city. On the sides, I have the map Fortaleza located in Ceará, Brazil, all right? Continuing, I collected my socioeconomic data from the IBGE, and IBGE is Brazilian Institute of Geography and Statistics. And here I collected per capita income, life expectancy, and population data in general. And I collected too the consumption data and the CAGES. And CAGES is the Ceará Sanitation Company from Brazil. And I systematized the data in per capita consumption. There is the lira per inhabitant day. Continuing, my method is decision tree, and the DTS can be used for regression or decision analysis. And on the sides, I have the illustration of the decision tree, and she usually starts with a single node, which breaks down into possible results. And here I have the first results, result 3 on the left, and the false results on the right. continuing, I used the Gini index with my decision tree. And the Gini index measures the degree of heterogeneity in the data. And the Gini index varies between 0 and 1, all right? And the 0 represents total purity. On the sides, I have the expression Gini. And here, P represents the probability that elements will be classified to a different class. So, I have the results. And the first result is the per capita income variable is at the 3 roots and therefore has the most influence on the per capita consumption of Fortaleza. And I verified the result also indicators that only 8 variables significant influence in the urban water demand. And I have the 8 variables and here more significantly. And that's it. Thank you for attention.
Okay, thank you for your presentation. It was extremely efficient, very short and very, how to say, clear. Since I read,
because the time is 5 minutes.
yes,
The presentation.
Yes, we read your abstract, which was submitted, and I have only one question for the beginning. I found that the classification of the water supply to people is very high, up to 800 liters per capita per day.
Yes, in here.
Yes, so does it mean that you really have so much water in this area?
About the 4,000 euro per in media, all right? And the
What are the
liter per inhabitant day. And in some same areas, the factor is more expressively, and in the areas the per capita income is high, the consumption per capita is high too. All right.
All right. Yes, it's very much important accounting not only for water demand, but also very much important for wastewater treatment.
Yes.
So the treatment plants must be huge.
Yes.
And the expenses for such a treatment plants are very big. It's very much expensive to treat so lot of quantity of water. Do you agree? Do you agree with this? It's very much expensive for big treatment plants, for a lot of wastewater, etc., etc. So I think that your conclusion that the income per capita is the major driving force for this conclusion, it's quite obvious. And if I may give a suggestion, you should, as a are you civil engineer, hydraulic civil engineer, or what?
Okay.
You should learn politicians and water and city authorities to decrease consumption of such a high quantity of water. Okay?
Okay, thank you.
Okay. Professor T, any question, please?
No, I think she made an excellent presentation. Of course, we would like to see if there is also any variations in the water usage, if different economic zones are considered. So that way you can draw the contrast that the water usage is mainly dependent on the per capita income as opposed to any other factors. So maybe a comparative study a little bit on another region will be helpful. That's my suggestion. Thank you so much. Very, very good presentation, very concise, and you have all the points across. Thank you.
Thank you so much.
Okay, thank you, Teresa, very much, to you and to all of your group. Okay, should we proceed to our next presentation, or we check if Aishwarya Avari came? I haven't noticed this name on this list. Okay, Catherine Villalta.
Hey.
I think
Okay, Anup.
Anup.
Okay.
Yeah.
Anup.
Anup is
Anup,
present.
welcome. Welcome.
Yeah. Thank you.
Analysis of the influence of estimation of on-farm carbon and greenhouse gas emissions across spatially and climatically variable locations in Texas.
Yes.
Okay.
So can I
Please,
share my screen?
Yes.
Yeah. Okay.
Okay.
Good morning. And our group, Catherine, she's mainly working on this, and she's not here today. So I got this opportunity to present. And for the last 3-4 months, we are working on this topic. It's estimation of on-farm carbon and greenhouse gas emissions across spatially and climatically variable locations in the state of Texas.
Okay.
And I forgot to say, we are from Prairie View A&M University. It's a part of Texas A&M system. It's located near to Houston, Texas. And as a background, if you consider the state of Texas, it's the in the agricultural production, it's 4th in position, and it's making about 20 billion, which is contributing to the nation. And Texas agriculture contributes about 0.75% of total greenhouse gas emissions in the United States. And as we know, our population in the whole world is increasing, and by 2050, it might be reaching about 9 million. So on the other hand, we can see the carbon emission is also increasing. So we need a conservative and sustainable practices in the agriculture sector for reducing the greenhouse gas emission from these crop fields. So the major greenhouse gas emissions from cropping system are carbon dioxide, nitrous oxide, and methane. And currently, this United States Department of Agriculture has developed a web-based tool. It's very easy to use, and usually farmers or ranchers and researchers are using it for quantifying the carbon emission from agriculture sector. So in this study, we have used the Comet Farm for evaluating the impact of different management practices like tillage, fertilizer application rate, and how it is influencing the greenhouse gas emission. So the materials and methods. Our study area, as I mentioned in the topic, it's the state of Texas. So Texas is classified to 10 climatic regions. And as you see in the graph, we can see the variability of temperature and precipitation across each climatic division. It's varying very drastically. For example, for precipitation, if you consider the climatic zone 5, it's called trans because it is getting the very less precipitation per year. At the same time, if you move to the eastern Texas, the precipitation is a bit high. So we can see a drastic difference in weather pattern of the state. And similarly, if you consider the soil type, there are NRCS has identified more than 60 types of soil across the state, which is the combination might be varying from sandy loam, sand, or yellow clay or alluvial soil. So in the study, basically what we did is we selected a single field from each climatic zone, and we assigned crop rotation like corn, after that cotton, and after that sorghum in the Comet Farm model. And the off-season is considered as fallow. Then we run the model for quantifying the greenhouse gas emission from each field, and each field represents a climatic zone. So these are the scenarios we considered in the study. First one is obviously the baseline, and with tillage and with intensive tillage, without tillage and with intensive tillage, and plus or minus change in the planting date and different rates of fertilizer application. These are the different management practices or scenarios we considered in our approach. So when I say this baseline scenario, we got some values from Texas Agriculture Extension. For example, in the case of fertilizer, if you want to produce 4,000 lbs of sorghum from an acre, we have to apply 80 pounds of nitrogen as a fertilizer. And in the case of corn, if you want to produce 6,000 pounds of corn, we have to apply about 132 pounds of nitrogen. And we have to irrigate those fields. So irrigation amounts we calculated based on an irrigation tool. It's called IMANSYS Irrigation Management System. And here are some results from our study. So as I mentioned, we have 10 climatic zones across Texas. For example, from a climatic zone located in the south or southeast, we have these results. We can see the baseline. Baseline is the amount of fertilizer, as I mentioned in the previous slide. And if we are not going for a tillage, or if it's with minimum tillage, the orange graph is carbon sequestration. So we can see more carbon sequestration and less nitrous oxide emission from the field. So we try to generalize it for entire Texas, and as you see here, if you go for the minimum tillage, it may not be possible all the time for the farmers if they consider their yield. We can reduce about 80% of greenhouse gas emission across the state. And obviously, if you consider the S3, the scenario S3, that is intensive tillage, and if we cultivate the plant, or if you plant, the planting date is shifted about 15 days, the emission is too high from the field. And yeah, as I mentioned, the non-tillage practice will not only reduce the soil erosion and carbon sequestration, it will help to increase the biological activity in the soil, and this will benefit the farmers to get more yield from their field and reduce the carbon emission. And these primary findings show the vital role of crop management, like minimum tillage in carbon sequestration and reducing the GHG emission. And I would like to acknowledge some grants from NSF and USD and NIFA for supporting this project. And yeah, thank you for this opportunity and listening to this presentation.
Okay, thank you, Anup.
Thank you.
If I pronounce your name correctly.
Yeah, it's Anup. Yeah.
Okay, okay. Since Texas is much closer to Florida than to Serbia, I would like my colleague T to express his impressions about this.
Yeah, thank you. Anup, it's a great presentation. I like the way you are using the Comet farm to try to find out the emissions. The one question I have is that, are you using the realistic farming practices, or these are hypothetical scenarios?
I mean, if you see the farming practice, like we added 25% extra fertilizer, that may not be realistic if you consider a farmer, because obviously they won't go for 25% of addition. I mean, they may not spend that much money, but we just want to show if we go for a severe application of fertilizer, there might be a high increase in the greenhouse gas emission. And we are trying for some other scenarios like split application of fertilizers that those farmers are following in agricultural fields, especially in Eastern Texas and all. So maybe for a clear picture of the realistic things in the field, we have to include additional practices.
Okay, so basically, what my question was, are these scenarios kind of representative of what is going on in Texas in different farms?
Yes, exactly. Yes. Okay.
So that way you can draw conclusions about the emissions based on the practices which are going on in Texas, right?
Yes, exactly. Okay. And other thing is for calibrating this model or evaluating this model, we need the values from each field. I mean, how much is the emission, but it's practically now it is not possible. So only way is we have to believe this model values. So
okay.
Yeah.
And what is the one final question I have is, what is the most sensitive factor for your GHG emissions based on the Comet farm model? Is it the fertilizer? Is it the tillage, or what is it?
It's the tillage. I think it's the tillage. Yes.
Okay. Okay.
So tillage, what happens is if it till more, then it will affect the microbial activities. So that will increase the emission. In addition, we can see the temperature. So as I showed in that graph, the temperature is varying drastically. So we can see more emission from the high temperature region. So that's also another thing.
Okay, very, very interesting and insightful study. I mean, I have not seen this kind of study, especially using Comet farm. I think it's a wonderful study.
Thank you. People just started using it. I think even I could not see much publication from this.
Yeah.
So most of the papers are from Colorado State because they are working on this, the USDA in the Colorado State.
Wonderful work. Keep up the good work. Thank you.
Thank you.
Okay, Anup, thank you very much. I would like to, if it is possible, of course, to provide me your report or anything more than abstract that I had read. Okay.
Okay. Yeah, I'll do that.
Thank you very much. Yeah. Thank you very much. Okay. Now we are proceed to the Rongxian Wang from Japan. Am I right with this pronunciation? Yes, Mr. Wang?
Yeah. Can you hear me?
Yes, we hear you very well.
Okay, so can you see the screen?
Yes, we can see the screen. Welcome.
Okay,
don't turn to Japanese, please.
Oh, yeah. Of course, yeah. Okay, and I will start. And today my talk is about the remote performance of Susquehanna 2 in wastewater by the membrane breakthrough and anaerobic. Anaerobic and oxic and conventional anti-slur processes. And as we all know that some of the study has been shown that SARS-CoV-2 was detected in the wastewater from the wastewater treatment plant to the effluent during the COVID-19 outbreaks. So actually the coronavirus is one kind of the envelope virus, and difference is between the envelope and the non-envelope virus, which is known the envelope protein carrier. So also some studies show that the removal of the non-envelope virus in the wastewater treatment plant by the conventional artist large and the membrane brighter. And but however, the behavior and the remote performance of SARS-CoV-2 is not yet in the wastewater. So that's why we focus on that. And for the objectives, we have three clear objectives. The first, to clarify the room performance of SARS-CoV-2 in the real wastewater treatment plants, and we will calculate the total log room value in the wastewater treatment plants. And the next, to compare the room performance of the three secondary treatment processes by the membrane brighter, conventional storage, and A2 and chloration in the SARS-CoV-2 reduction. And finally is to evaluate the applicability of the PMV as a process control for the SARS-CoV-2 wastewater. And for the we conducted the sampling of the SARS-CoV-2 in the wastewater treatment plant by the three parallel processes. And for the method, we collect the influent and effluent sample from the wastewater treatment plant, and we separate the influent to the PEG precipitation. However, the effluent, we will directly go to the PEG precipitation, and then we conduct the RNA injection and to quantify the citizen1 by the qPCR. And for the result, however, we cannot find any relationship between the SARS-CoV-2 concentration in the wastewater and the COVID-19 confirmed cases. But the total concentration of SARS-CoV-2 RNA was 3.3 to the 6 log copy per liter in the influent. And in this result, you can either see the log range value from the in range of the 2 log to the 4 logs. And in the left figure, by each of the processes, and the right figure shows each process's log range value and the total log range value in the wastewater treatment plant. So the final result, we evaluate the applicable virus indicator of the PMV in the wastewater, and we got one conclusion: the log range value of the PMV is lower than the SARS-CoV-2 in the wastewater, so that the PMV is a good performance indicator. So in our conclusions, the first is the total log range value after disinfection was over the 3.5, and we also compared the others typical log value of the non-envelope enteric virus. And for the removal of the SARS-CoV-2 in the second treatment plant by the treatment by the membrane brighter was more stable than the conventional artist log. And for the removal by the A2 processes was not significantly different with cost processes in my study. And the final one is the PMV is a good indicator virus to evaluate the removal of the SARS-CoV-2 in the wastewater treatment plant. And we also not only focus on the SARS-CoV-2 in the wastewater, but also the antibiotic resistance in the wastewater. So if you're interested in this topic, you can contact me. Yeah, that's all my presentation. Thank you.
Okay, thank you very much. It was very efficient.
Yeah,
and your conclusion that MBR technology is quite okay is challenging, and it's because in the worldwide technology used So maybe it is something that should be emphasized even more than you did. You agree?
Yeah, I agree that the membrane is one kind of the advanced processes to compare the the conventional processes in the wastewater treatment plant.
Yes, I think it's nice for people because we know that Japanese technology is very much advanced compared to let's say average technologies applied to wastewater in the world, not to some top positions at top countries, but generally speaking, MBR is also could be applied in even modest income countries in the world. So that's okay.
Yes.
That's nice conclusion, if I may say.
Thank you.
Colleague, yes, just a minute.
Dear Johan, open your camera.
Oh, sorry.
You have
Sorry,
the camera
I
closed.
didn't. Sorry.
Okay,
Sorry.
fine. Thank you.
Okay, thank you for reminding me. And our colleague T, any comments?
No, I think you have done a wonderful job of presenting your research very concisely. And recently, we have some efforts on trying to find out the COVID virus in our wastewater systems on the campus, on our university campus. And we found out that whenever we see high values, there are more incidences of COVID cases in the student apartments and so on. So that's what we have noticed. So this work is mainly to one particular treatment plant in one city, or is it multiple cities?
Yeah, actually it's just one city wastewater treatment plant. Yeah.
And what is the need for you to evaluate the reduction in the COVID or SARS-CoV-2 virus? What is the need for that? Because you are adding that water back into the system.
Yeah, actually the SARS-CoV-2 was already detected in the target city, in the wastewater from the influent to the effluent. So that's why we want to calculate the local value.
Okay. So I see that you have already published a couple of papers also, right?
Yeah, maybe publish. Yeah. Okay. Thank you for your advice. Yeah.
Thank you so much. Very good presentation.
There is, sorry to interrupt, but there is a question in the Q&A for Rogue One.
Yeah.
Yes.
Yeah. Hold on.
Question, please.
Yeah, actually, we not evaluate how much the duration of the SARS in the wastewater, but some technology cover both virus. Right. Yeah, we just quantify the virus in the wastewater because we take the. Okay, I will share this one. Sorry. So we just take the wastewater treatment samples from the plant and to separate the influent and the effluent. So some of the SARS-CoV will contain in the influent or the effluent. We just do like this one.
Okay, so from one treatment plant it was taken.
Yeah.
Okay. Do you want anything more to add?
Yeah, I think no need anymore to add because we just already compare the PMV performance indicator. So I think we don't need to add others variables. Yeah.
Okay. Thank you very much. Thank you very much.
Thank you for your comments. Yeah.
Thank you.
Okay. Shall we go to the next speaker? Antidius Rafael. Is he present?
Yes, Amen.
Okay.
Thank you, and kindly allow me to share my screen.
Yes.
But I think the other screen share, I think, for a mistake.
Roxanne Wang should turn off.
Raksham Wang, can you stop sharing the screen?
Yes. Okay. Thank you.
Okay, thank you. I trust you can see my screen here, right?
Yes. Yes. Thank you.
Okay, thank you first for the organizers for organizing this insightful the Congress, and I'm Antidius Rafael. I'm like a Tanzanian youth, but I'm currently accommodated at I'm taking the Masters in Applied Ecology that organized by the consortium of universities in Europe, but also in Tanzania, have some connection with the UNESCO Channel Ecological Science Boundary Water Management, but also the Youth Network and the World Youth Parliament for Water, but also part of the youth, Tanzanian Youth Parliament for Water. And here I represent about the ecology for sustainable water resource management and climate change adaptation, and calling for a special action to mobilize youth for sustainable actions. So actually, I'll start with the overview regarding the water, and I just did the review of the World Bank and the World Bank water report. They just pointed out like over the, more than 40% of the global population are just water scarce, and then this has been exacerbated by the increase in population. That to exert more pressure on the water resource, but also it's going for like about 7% of the deaths that are due to natural disasters are water related, either due to excessive water or shortage of water. And the situation has also been worsened by the climate change incidents that caused the greater alteration of the hydrological cycle, and due to the occurrence of unpredictable floods and droughts that worsened the problem. Africa has been in a special case. And actually speaking of Africa, I call for the special youth mobilization, because it's also documented that more than 50% of the African population is youth. And here I just want to call attention on what I call the hydroclimate escape, due to the increase of population, and most I call it urbanization. You can say that if the water provision infrastructure that are there are maintained to be the same, but from time to time the urban population is still increasing from year to year, from time to time. So we'll be having the failure in problems, the normal function of the water provision systems, but also the reduction in green spaces due to the creation of impermeable surfaces. We'll be heading to face we have two major problems: the problem in water supply, but also the changing our urban microclimate. And also these will interact together with the increasing population and the climate change incidences to further lead to surface water pollution, but also the flooding incidences in urban areas. So just to figure out this one, I say this, we should have a systemic and an integrative approach that can curb all the challenges, but focus on enhancing the nature-based solutions using the natural ecosystem. It comes the concept to ecology that it's a nature-based solution and a systemic approach that aims to solve water problems in ecosystem by enhancing the resilience and carrying capacity of the natural ecosystem. As you can see, this is the pictorial presentation of the ecological concept, showing the different techniques that can be used to alter and enhance the captivity of the natural, the carrying capacity of the ecosystem to increase the resilience to pollution and some climate change. So its operation is based on the key principles, and the first principle is hydrology, or we can say the quantification process. And here we need to quantify we need first to figure out and explore the major process that are occurring in the hydrological cycle that can be altered to modify the amenity to enhance the the carrying capacity of the ecosystem in the regions. But the second principle is ecology, and then here we deal with the with the identification of the potential ecological processes or ecological functionality that interact with the hydrology, to come to the third principle, that is ecological engineering, or we call it the georegulation, because we did like regulate hydrology to modify biota, and we alter biota to shape the hydrology of the certain ecosystem. So it's like the integration of hydrology, the hydrology and like the ecosystem and the ecology and the hydrology. We come to georegulation. So in this paper, I just used two methodologies. The first one is like did the critical review on the global application of ecological techniques in solving water problems, water pollution, and climate change problems, especially in urban areas. But also I did some field visitation in Poland where it has been applied. In Poland, it was my focus was on the sedimentation biofiltration system that was used to reduce the risk of contamination in the Jeronica lake that was like under the risk of accumulation of algal blooms and eutrophication due to excessive release of pollutants from untreated sewage and agricultural areas. So here I presented in the first part the typology of the setup of the sedimentation biofiltration system, having the sedimentation zone to enhance the sedimentation of suspended particles. We have also the gabion and microfilter in between. And then after that one, some trace of pollutant that remaining will be captured by the native vegetation that can could be with the system. Then we have the outflow of the treated water. And here I just present the top view and the side view, but also after this typology in a series, his performance was gauged and depending on the by like monitoring the concentration of the percentage reduction in the forms of nitrate and phosphorus that are the major symptoms of eutrophication. And then we see we obtain like a significant reduction in all forms of nitrogen. You can see, for instance, nitrate, we have 73%, while ammonia was reduced by 99%, while phosphorus was reduced by 52%. The first case, but the second case was like the Lake Naivasha in Kenya, and they use the other product constructed wetland. So in here it's like you can see the location, the geographic location of Lake Naivasha in Kenya. And the typology and the idea behind the constructed wetland, like we also use the same vegetation, the ecosystem components, the natural vegetation to mimic the normal functionality of the natural wetland to filter water and increase the captivity of functionality of the ecosystem in its resilience. But its performance will like after degrading the pollutants, the documented performance will like the conductivity and total dissolved salts reduced by 29 and 67% respectively, while the total suspended salt and biological oxygen demand all decreased significantly at 95% confidence interval. But also the last case, in the case of water treatment, it was in Ethiopia, where it was the sequential biofiltration system was used to rescue the degradation of the Asela Lake. It's located, you can see the Voltu Reservoir in the where the Asela Lake is. So this, and you can see the typology, the sequential biofiltration system set up before reaching the final destination, the Asela Lake. And then here I just presented the percentage reduction in the pollutants, focusing on total nitrogen, total phosphorus, organic matter, and mineral matter before and after. So you can see, for instance, in total nitrogen, before we had the percentage reduction of -24. It's like there was a huge accumulation of nitrogen, but after intervention of this one, we had it achieved like 76% reduction in the total nitrogen, the same to other things. And you can see for total phosphorus, it was reduced by about 93%. So this is the first facet, and then you consider in the note I say that the hydroclimatic cascade, like present like there's the concept of water and water problems, either excess or shortage of water, but also the other side was climate change due to the increase in urban, due to the decrease in green urban spaces, and the creation of impermeable surfaces. So in here, once the green urban spaces is reduced in urban areas, will create some kind of called urban heat islands. So we usually have excessive heat in urban areas due to congestion of buildings, vehicles, and reduction in green space. So ecological intervention are also there through the application of blue-green infrastructure. What does that mean? Like the integration of blue component standing for water and green component standing for vegetation. So these are several interventions to reduce the urban heat island. The first, you can see the green park. So this is the demonstration of the bicycle parking system. Then there's like green spaces in the city centers. And this one you can see on the right-hand side of the screen, or the top one, you can see it's called Klima Pond, or it's like a climatic pond. And this was constructed several schools to increase the adaptation of it. And then, but the typology of this one and the last one, it's called the green, the treatment system. They all collect the stormwater from the dome, from the roofs of the buildings, and all water that's coming from the stormwater in the area they're constructed. They turn it together, and then the vegetation just planted around. They filter the water before getting to that pond. Where the pond, it will be channeled to the ground and the ground collected, and then where they are because they are already like treated, they're treated to be used in maybe fields or content to reduce the incidence of urban flooding. So because I say they saw they revealed a good performance in terms of primary regulation, but also management of water resources and preventing pollution. I call for a great attention to mobilize the African youth, because we know that in Africa there are several water bodies, but also a great population in Africa, but most of the African countries are developed in, so it's facing like a high rate of degradation. So the foundation of what I call like the African Young Ecology Association will be like a way to increase the adoption of these techniques through the vertical horizontal integration. Vertical horizontal integration, I think vertical integration like from the grassroots, from the community level to the national and regional or the global level to implement these technologies, but also the horizontal integration like from community to communities and all the other institutions that are operating in the ground, but also to build the gap between science, data, and practice, because I recognize that there should be like a remarkable role of the indigenous communities, and the local communities need to be brought in the loop so that we increase adaptation of these technologies through capacitation of communities, but also to make the process and the adoption of the concept more sustainable. We need to reach out into schools and in local communities, as I said, so as to reduce the degradation of ecosystem and to reduce some incidents of hydroclimatic disasters through dissemination of these technologies. So as I said, in this typology, this is like it's like a schematic model. We have the transparent. We have two approaches: top down, that's like a decision coming from the top levels. These are usually like the usual cognitive based and problem focused. They focus on certain problem, but based on research and projecting futures. But once we have the local communities they usually use the bottom up, like they themselves, they don't have research, but they are experienced driving. So they know actually what's happening in the ecosystems in their vicinities. So that's why I propose like to make this, the movement sustainable, we need to make these approaches. So we integrate the research based approach from the top levels with the experience based approach from the communities. And to make this happen, we have youth, because youth are the key component in the sustainable intervention, because I can say that they have already experienced what is happening now, but they can be able to, they are available to rebuild the same the next generation. And for instance, if I go to these building infrastructures, we need to be having maybe green buildings in urban areas or in whatever area where the population is increasing. But all the youth are the ones that are going to be like planning for the new cities. So they are the ones that need to adopt these technologies. Yeah. So the foundation of this like association of the network that will bring the youth to make sure the sustainable movement and they act on mitigating the effect of climate change and harness the degradation of water resources will be essential to make it happen so as to ensure the science for a secure world in a changing environment, I can say. So this can be done through the harmonization, the integration and demonstration of actions, because we need to upscale what have been done from local scale to national scale, to the global scale. And this will actually start from the local communities. Thank you for your attention. That's the end of my presentation.
Thank you. Thank you. It is nice that you concluded your, if I may say, your activities and cooperation with Professor Maciej Zalewski by organizing this association of young people in Africa. Is it in whole Africa or in a couple of countries?
Actually, I'm just proposing this because I propose that it can be in Africa, because if I take like what I'm taking this program of applied ecology, that's what I got the experience, and actually I met with Professor Zalewski. We have several people from Africa. We have some people from North Africa, we're from East Africa, and actually I'm from Tanzania, which is part of East Africa, with some from the West Africa. So we're like, if we can get together, and once we've integrated with the several UNESCO institution to make it happen. So like we can make it like from different parts of Africa and with different stakeholders and different backgrounds.
If I may suggest, you can make some UNESCO center down there in one of the countries that dealing with such a problems, because it could be a much more efficient approach than we used to experience in the past decades to encompass the problem from the both sides, quantity and quality.
Yes.
Accounting for a lot of problems with water in Africa. So I don't have any other comments. So please, Elpida or colleague T, any comments or suggestions?
I think it's a wonderful presentation. I really like the way the eco-hydrology and the low impact development options are helping to improve the water management as well as the quality management. Now, are these options, are they driven by water management agencies, or there is a lot of interest from the public, or where is this focus coming from?
Actually, what I presented, all the intervention, like all the intervention has been like established, and they have been conducted with the UNESCO chairs. For instance, that in Poland, of course, even that one in Ethiopia and Kenya was like demonstration from Professor Maciej Zalewski, and that in Poland it was under in Poland it was under the European Regional Center of Ecology, where also Professor Zalewski is based. But also in Tanzania, there is a UNESCO chair, but it's like it was established, so it is still so young. Yeah, but all the intervention like under the influence of UNESCO chairs and UNESCO centers, ecological centers under the auspice of UNESCO.
Okay, so it's very interesting study, and then the results presented are also very interesting. That might help. These days we have more focus and funding for the green infrastructure, especially in urban areas in the United States. We are also creating more awareness for the public so that they can try to improve the stormwater management in their local areas, having this green infrastructure established in every part of the city. Some of the well-crowded cities in the United States are already implementing downtown local small reservoirs, sub-reservoirs within the cities so that we can trap this water immediately and then clean it for future. So it's very interesting, and I think that is the way to go to improve urban stormwater management problems. Thank you so much for a very insightful lecture.
Thank you. I appreciate it.
Thank you very much. Elpida, would you like to add or comment something? You are muted.
Muted.
Yes, sorry. I'm just wanted to say congratulations on your presentation. There is a question for you. Please, Ramesh or Jovan, just
Yes?
can you see it? It's in the Q&A for, it's for
Ramesh? Okay,
Didius.
Ramesh.
Yes.
No?
Let me
Just
see.
read it too so that we know.
Okay.
Yeah. Thank
There was
you.
a question for me. I think any insights on predictions on frequency and intensity of storms across different cyclone basins around the world in the context of climate change? Yes, a very interesting question. This is an ongoing work in different parts of the world, especially those areas which are affected by hurricanes or cyclones or typhoons. There is also a research which is going on in terms of the atmospheric rivers. For example, on the western coast of United States in California, they experience what we call atmospheric rivers, where they dump a tremendous amount of water in the form of precipitation, which leading to flooding. This is a short-term amount of rainfall, but it is huge. And there is a prediction capabilities that are being going on to improve that prediction. But of course, because of the advantages of satellite and so on, we can look at that. In terms of the frequency and intensity, yes, they are going up in many parts of the world, including United States. For example, we have seen more extreme rainfalls due to hurricanes, or we call cyclones in other parts of the world. We call it hurricanes. And we also see the intensification of the energies associated with the cyclones, bringing more destruction. So the attribution to climate change has to be confirmed. We are still working on that research in US and other parts. So that's what is my answer. Thank you for the question.
So there is a question also for Andidius. Yes, please.
Yes, I can't see. So if you can read it for me.
Okay. I just read it for you. Any experience in working with eco-hydrological measures to promote groundwater recharge in aquifers, hence increasing water supply in rural areas? If you push the Q&A, you will find it in front of your screen so you know.
Okay, I see.
Okay?
But
Okay. Thank you.
Yeah. So, okay. So just by responding, for what the intervention I've seen, I know that by increasing the captivity, I mean the carrying capacity of the natural ecosystem, which will be also increasing the recharge to the underground aquifers. But as far as we have done from whatever we have done in Poland, it was based on the surface water. I mean on the surface water. But probably once we increase the carrying capacity of the river and carrying capacity of the ecosystem, we increase its captivity, hydrological captivity. So meanwhile, we'll be increasing the underground, the recharge to the underground water. But I haven't worked with that one, that specifically inside on the recharge of underground water. But I believe it's there. And I suppose like Professor Zarist knows more. Maybe I can share some resources for there if you need it. Yeah.
Okay. Since we do not see any more questions, no requirements, I would like to thank you. It was very nice, and I think I found it is very much important for arid and semi-arid areas in the world. So Africa is one of those, and I guess it would be a very nice, promising opportunity for treating water even in small communities, in villages, and in oasis, etc. I find it's very much promising. Thank you very much.
Yeah, thank you. And that's the reason that I was posing if you can do it, because I also believe that for any intervention to be sustainable, we need, of course, to achieve the global agenda and international agenda, but we need to start from the local communities, because if it can be implemented and if it succeeds from the local scale, from the grassroots, then it's easy to scale up. Different from if it starts from the higher level, but the local community that are living with the resources are not aware. If we start with the communities and then we impact more knowledge on the growing generation through schools and young generation, the youngsters, I support that to make a sound impact that will be then it will be sustainable.
Yes, I agree. Yes.
Okay, thank you.
Thank you very much.
Thank you.
Thank you very much again. Okay. Okay. Mr. T and Ms. Elpida, do we have any more comments, or have we found this Aishwari Avari from India, the first presenter who was not there?
Did we miss 2 presenters today or 1? I think we missed
only 1, the first one.
Only the first one?
Yes.
Maybe she's not attending today, so maybe she'll contact the Congress to find out another spot somewhere to present.
Yes.
She didn't contact yet, but maybe something happened. But we
Yes,
still
tomorrow.
have one.
Tomorrow, maybe.
But we do have one, isn't it? We do have one
From Spain,
from Spain.
Liatas
Yes.
Palomero.
I think he's missing. That presentation is missing. Two presentations. That's why. I said-
Okay, so this is also missing, this presentation
Liatas
on
Palomero
flood
from-
prevention at Balearic
Yes,
Island,
Yes,
Spain.
yes.
This, I don't know, because they already sent the revised versions and everything, and maybe something went wrong. They didn't reach the committee just to see. Okay.
Maybe tomorrow. Who
Maybe
knows?
Yes, there are still discussions
Yes.
on theme 1. In theme 1, we also
Okay.
have another session next day.
Okay.
Okay.
Right.
So
I don't
we
know.
can conclude that it was a series of 9 nice presentations. Young people jumped into these waters, muddy waters, urban waters, and other waste waters as well. And we missed this flooding for Balearic Islands, but maybe tomorrow or some other time we will listen for this, because it is interesting point from the construction in during tides and some other extremes, water extremes, so could be interesting also. Okay, I would like to thank to both of you, and I think that this was not a bad experience. On the contrary, it was very good experience. So if we continue this way, we will improve ourselves and also the young researchers in the area or worldwide.
I think so. I echo the sentiments. I think this was a wonderful forum, and the young researchers, they are also very much interested in presenting what they've been doing. And I think to learn experiences from different parts of the world, that is also a very beautiful montage of all these presentations for us. So thank you, Elpida, for coordinating all this effort.
Can I ask something?
Yeah.
Of course.
Yeah, okay, turn on my screen. I would like
Yeah.
to also based on what I proposed on my last slide, how can you advise on that one if we can create that like a kind of ecology network that will be operating from the local communities, but also feeling in the global agenda, but because for sure, as far as you know, like there's the launch of the 9th phase of the hydrological or the UNESCO IHP phase that will be discussing on the bridging the gap, reducing the gap between this data science and some kind of application. So I just wanted to see if we can, if that one, what I proposed can be feasible and can be implemented, or it can be found. And yeah, that's why I wanted to gain your insight, and if there is something maybe you can advise or something you can say to make it further.
Ramesh?
Yeah, I think
Yeah.
you know, I'm very favorable to having that particular dialogue, and then having this whatever you are proposing to go beyond the area. So I'll be happy to collaborate with you to talk more about the initiatives you have started, and then help you in any way connect with the researchers who are working in the same area, especially the low impact development, green infrastructure. We also are focusing on green design for all our buildings. So in many places, laws are in place that we have to construct zero emissions and zero water wastage, quality concerns. We call it as LEED buildings. So every building is now going through that certification process. So I will be happy to connect with you. A very interesting study, and also a lot of insightful small case studies you have presented. I'll be happy to connect, and you can find my name on the internet, and you can write to me, and I'll be happy to connect with you.
Okay, thank you, I appreciate it.
Thank you.
Just before Jovan, I would say that we will try to insert a list of all the emails of the mentors, so that you have the opportunity in case you want to reach someone. We have 17 mentors throughout the country. We have 3 experts on the round table and 2 keynote speakers. We will provide a list of all these names so that you have the opportunity to get in touch with them and their networks.
Okay, thank you.
Okay,
I appreciate it.
Please, Jovan.
Yes, I really considered similar things, but they were not completed for the area of Central Asia because of very sparse, distant villages, small cities, and there were no capable and big companies, group of people very well educated, etc., for some complex solutions. But this kind of solution is very much promising, as I said before, for villages, for distant places, small places, etc. Also for cattle and for people. It can be also considered as a rainfall harvesting to a certain degree. So this is something which is very much in compliance with fight against the climate change. Seeding the trees and collecting water everywhere. As I noticed on the Caspian Sea, in the area of the northern or the western part of the sea, of the lake, we noticed holes in the stone where people used to live 10 or even 15,000 years before the Christ. They were collecting water in the stones and small depressions for some kind of irrigation, drinking purposes, etc., etc. So it was a distant place from the main village, etc. I think it's very much promising, and I would like to support you. If you need some support or any advice or anything, please contact me, and you will have this information via Elpida Info Center. Okay.
Yes.
Thank you. I appreciate that. I'll be doing a kind follow-up. Thank you.
Thank you.
You are welcome. Okay.
Elpida?
Okay, I think since we missed the last presentation, and since we had a good small talk with all the other participants, I would like to ask if any other participant would like to comment or ask the mentors anything else that they would like to commence a discussion. I just repeat that after the end of this Congress, we are going to provide a list of the emails of all the mentors and experts. We will also provide the presentations of the mentors.
Okay.
If they agree, we will gather all the presentations and we will
Okay.
upload them to an e-library. And we are also we are on the path to produce the e-proceedings that we are going to share.
Okay. Yes.
We will inform you where we will upload this material,
Okay.
electronically, of course. We will send the emails as soon as we are ready, that we have gathered all this material.
Together with the presentations of the researchers.
We have
Yes.
the abstracts, yes,
Yes,
the presentations of the researchers.
Yes.
We will ask whoever would
Yes.
like. We will.
Yes.
We have also we record all the sessions, so we will also
Okay.
upload all the recordings. But
Okay.
separately, we will ask the mentors to give us their presentations, to upload them in a
Okay.
file so everybody can reach. And I think that wherever we provide this list of emails, all the participants and the attendees and anyone who likes to get in touch with all of us, there would be there all the information to reach.
That's nice.
Okay.
Once again, I would like to thank you.
Thank you.
It was not a small job. It was rather important and big job to collect at one place so dispersed people worldwide. Thank you very much.
Yes, we are very happy. I need to tell you, we are very happy that we have people from almost 30 countries all over the world, which is very nice that we can come here and have 3 days to exchange discussions and experiences and everything. And this is what it makes worth of this specific Congress. And this is what it makes it different than the others, because it's not only the part of the papers, which is today and the half day tomorrow. I just need to remind you that there is also a very nice session tomorrow of a water advocacy training that our young colleagues from the World Water Forum will provide a strategic approach. And then there is also the third day, a very interesting roundtable on what is going on the water jobs. This, I find it very, very interesting. At 8th of April, we have organized a roundtable. We have invited 3 experts, Josh Newton from USA, Susana Montenegro from Brazil, and Fidi Kunduri from Greece. And they are going to give us insights on what is happening on our water sector job market. And we are going to discuss, and you are very much welcome. We have a big slot because we thought that it would be very interesting to have interactive discussion, not only the presentations, but the questions. Much more the questions on where is this sector going to go, especially since COVID, a lot of things have changed.
Yeah.
Now,
Have you provided information in this regard?
yes, it's in the, we have, if you go on the website, there is a separate flyer. I will send it to you. I have sent it, but maybe it's very many emails, you know.
Okay.
But this roundtable is going to be settled on Friday,
Perfect.
8th of April, 1 o'clock Central European time. So we all be there.
Okay.
Okay.
All right. Thank you so much.
Thank you.
Thank you so much.
Thank you, Elpida. Thank you, Ramesh.
Thank you.
Tomorrow.
Thanks
we'll be
to all of
back.
the
We will
presenters.
back. We will be all the session tomorrow will be held on room 1 because it's the
Okay.
only day today that we had 2 rooms,
Okay.
parallel sessions. Tomorrow and the day after tomorrow, all the sessions will be held in room 1. So please, tomorrow, if you like, we have an introductory keynote speech from Professor Dries Quazart from University of Rabat, Morocco,
Okay.
that he's going to talk on emerging water challenges since COVID.
Okay.
We also have the rest of the sessions on the other themes, and afterwards on the evening we have the advocacy WASH training for the young
Okay.
people.
Okay.
Okay.
You might be knowing Simonovich from Canada.
Yes.
I mean, I'm asking you on. Do you know Simonovich?
Yes. Actually, I started my student practice with him.
Okay.
Mm.
Very small world.
I won't tell you when. I won't tell you when it was.
Yeah. I finished PhD with him. So he was
Oh,
my
yes.
he was my PhD advisor.
When he was in Canada or...
No, he's still in Canada.
Yes, I know, but before he was in States, I think.
No, he was in, for his PhD, he was in UCLA.
Yes.
Sorry.
yes.
And then he moved to Canada
Okay.
for his professorship. So
Yes,
I worked
yes.
with him for his PhD, for my PhD.
Okay.
Okay, thank you.
Okay.
Okay.
Thank you very
Bye-bye.
much. Thank you very much all.
Bye-bye.
Thank you.
Bye-bye.
Thank you all of
Bye-bye.
you. Bye-bye.
Bye.